Hi, friends. Welcome back to the Regenerative Agriculture Podcast. This is John Kempf, and today I'm here with a guest who I've wanted to have a conversation with for a long time, Erwin Westers. Erwin, you know, it's so easy for us in agriculture. We all understand that we have our own unique local context, and our local context is different. We have to adapt practices from different areas to our own areas. But I've been really intrigued by the direction you've taken your operation and the number of practices that you've incorporated that I don't see quite often. I don't see very commonly in production scale agriculture here in North America. I don't see people spreading mulch on a scale of hundreds of acres, for example. So I've been looking forward to our conversation, to learning more about your operation, and to seeing what we can learn from you. Tell us a little bit about your context and the scope of your operation, the work that you're doing today.
Yeah, thanks for having me, John. Um, we have a biodynamic seed producing farm in the north of the Netherlands, all at the border of the sea. So we own a part of the dike that holds the Netherlands dry from the sea, and we own a part of land that is outside the dike, which is a salt marsh. And it is in that climate that we have developed a seed production system under a biodynamic certification, in which we try really to go some steps further in putting a lot of quality in the seed.
What are the various crops that you're producing seed for?
We are producing seed for potatoes, so which is a tuber, but it's a seed potato. We're producing for radish, for kale, for turnips, for nasturtium, a lot of wildflowers also, and lupins, and a couple of others. And that varies every year because we have a couple of seed buyers, some of them in the German part of Europe, so in Germany, Austria, and Switzerland, two in the Netherlands, and even one in North America.
So you've mentioned a couple of pieces that I'm interested in. You made mention of trying to produce higher quality seed. What does higher quality seed look like exactly for you? What are some of the parameters that you're trying to achieve, and how are you approaching that?
Yeah, like if you buy a seed, most people look at the germination rate, and that is one of the most easy to research quality parameters of a seed. But figure is also one that most seed companies research, but they don't always put that on the label. And what we have seen is that by giving the seeds a very well life on our farm, that the farmer or gardener that buys the seeds has a better plant the second year. And we have seen that too. And it was kind of um, aha moment, so to say. It was 10 years ago, 2015, when we produced seed potatoes, and we had of this one variety, not enough from one farmer. So we went to two farmers to deliver us which was in this case a conventional untreated seed potato, in the same amount, about 3 bags that we put on the same amount of land next to each other. And the seed potatoes were optically all the same. They were fine, they were without optical disease, and they were checked in the laboratory. And the field was treated all the same. And then when we harvested, we harvest in crates, and I myself am on the harvester. I saw that the one part of the field where the other seed potatoes from the other farmer were used, there was much more rhizoctonia disease on disease on the tubers, so these black spots, which have to be thrown out all because they damage the next sprout the next year, and the yield was 25% less, which was just, and it's very easily because we could count the boxes, and there were 25% less boxes of that field, and I was like, so that farmer of who I bought these seed potatoes did something with that seed potato crop that gave me a better or a worse harvest. And if that holds true for a seed potato, which is a big storage canister of nutrients and
Right, it's got a lot of reserves.
yeah, but then that must also translate to smaller seeds, you know?
How do you measure vigor?
If you have, I think they do it, I don't know it exactly, but I think they do it like that. If you have different seed lots and you put them next to each other, you can clearly see what the difference is. And I don't know how you score it by then, but the one who grows rapidly or develops best at the first, 2-3 weeks, when most of the energy is coming still from the seed, that one I think will have the most vigor.
I had an experience several years ago, and I related the story, and I'm a bit fuzzy on the details at the moment. But a friend of mine purchased arugula seed from a mainstream seed supplier, planted most of what he had purchased, and had some left over. And that arugula seed that he planted, he harvested most of it, but some of it he let go to seed. And he had worked for years to build up his soil microbiome and soil mineral balance. And he harvested seed from some of the arugula that he had planted, and he had much larger seed size. He had about a third of the seeds per pound as the original seed that he had purchased. And then he planted what he had left over side by side with his own seed for the next crop. And his seed that he had saved from the larger seed size reached harvest size 11 days earlier than the seed that he had purchased.
Yeah, I think I know who you're talking about. I heard the same story.
Yeah.
And it's exactly that, and we have that in a few cases only. There's only this one seed company that also lets us produce the stock seed. And that's nice because then we can also replant that as, how do you say, the next generation seed. And we see that from our own seed, which has had 1 year at our farm, does it much better the second year than the seed that we get provided otherwise, which is also a problem with the big seed companies, that a lot of the stock seed is produced in greenhouses under very hygienic conditions because they're afraid for every kind of virus, disease, whatever. But that means it's a monoculture always. It's a
Is it grown in
conventional
sterile
managed
media?
crop. Excuse me?
Is it grown in sterile media?
That soil, is that sterile media? I think almost. Yeah.
Dead soil is a sterile media. That was awesome, Erwin.
And
actually, it might be worse than sterile.
Probably. So we get that seed as a stock seed, and then you have to make best of it, and that's not always easy, because if you have this first phase of the plant, and especially with all these brassicas that we grow, the first 2 weeks that the energy comes from the seed and also the microbiome, we must have a very strong plant. But when it has had that life previously in a greenhouse on a sterile medium, that's hard. And we have a lot of, these infant pests, or in the infant stage, like a flea beetle, that come in, and we tried helping the seeds with nutrition and with compost extracts and stuff like that. And that's still a hard one. We now try to solve this, and that seems pretty effective by putting it in a companion crop. So we have a mixture of the brassica with the buckwheat, a fenugreek, and a flaxseed. And that seems, if that comes out as a mixture, it's a very common thing they do in the UK and in France with the rapeseed in August when they sow it. But it seems to be working pretty effectively in spring in our region too.
So are you actually harvesting seed from that combination?
Yeah, but since we pick the seeds in that size that is very easy separatable, it gives no problem for us. And that is what we do with all the seed crops that we do. Most of them we try to sow in a combination, but they have to ripen at the same time. And all of them we sow together with an undersowing. So that means in most crops, we go in spring to the field with about 5 till 10 kilograms per hectare of the actual seed crop, which can be a mustard or a garden cress or a radish, and then about 15 till 20 kilos of an undersowing. So you go with more seed relatively to the field that is not there for a harvest than that you are with your cash crop. And we have chosen those plants in the last 20 years that we developed this system very wisely, so that they do not, when they get harvested with the seed, that they have a seed size that's very easy separable. But most of these seeds are perennials or biennials, like grasses and clovers, so they won't produce seed the first year. They will stay vegetatively, and that is the main goal of this understory, because all of our seed crops will have a generative or a vegetative and a reproductive state, as you know. Some of them have that in year one and then in year two, and a couple of them have that in 1 year, the annuals. But it means that there is a big part of the season that there is no photosynthesis um, products really flowing to the soil life, and there is where this undersowing takes over. So when you see that it is mostly in June and July that these crops turn to flower, they make buds and they turn flowers. Then they ripen in August, September, and then you harvest. It means that the most photosynthesis intensive period of the year, if you look at your photo cells on your roof, you do not have photosynthesis growing in a vegetative plant through the soil life. And as if you have explained that previously, as Christine Jones, that is a very important food source, and of course it's about the harvest of that year, but the harvest of this year is the prerequisite of the harvest of next year.
Yeah. Yeah. So you are trying to optimize your understory so that it is in a vegetative state and photosynthesizing, while the seed that you are primarily targeting and growing is in the reproductive state and is not at optimal photosynthesis.
Yeah, exactly. And that's mostly in
Yeah.
the summer months when it's not as hot here as in some regions of the world, but it has gotten a lot hotter and drier last years. But still, though, our main photosynthesis gift that we get for free is in those summer months. And in a normal situation, a seed crop would be harvested in August, and the soil would be tilled shallowly, and a cover crop would be sown. That would mostly be a freeze, a frost vulnerable cover crop. So that means in November or at first frost, that would be killed again. And if you add up all the vegetative photo energy that you get in a year like that, it will maybe be maximum 3-4 months of the total 12 that you harvest photo energy. And it's not the most photo intensive months of the year that you do that, so not in middle of summer. And when we have a system, when we have a seed crop after a seed crop, which is an annual with an undersowing, we have about 48 to 50 weeks of the year a vegetative growing crop.
Wow. So if I'm understanding you correctly, you have kind of three different strategies that may overlap. You have a strategy of planting an annual intercrop, if you will, an annual into a biennial seed crop, or vice versa, where you're planting biennial intercrops with an annual seed crop, or you are planting seed crops that have two very different seed sizes that you can easily separate. Did I
Yeah,
track that correctly?
yeah, you tracked that correctly. Um, and as said, the undersowing is actually it's a biennial, but it is often a perennial, um, and that is one you could also let stand in the next year. But then we terminate it again, and the next crop comes in, and it can be a potato or a carrot or a next seed crop, and
Mm-hmm.
it is this. It is pretty constant in our farm, and it's also in spring. It's pretty constant what you have to do. You have the same situation to start from. And it has not been easy figuring out what plants to put in the understory and how to manage that, because we have a lot of different seed crops, and we are trying to find a little bit one size fits all. So in the olden days we had a lot of different mixtures put under it, and now we have actually one which we vary a very little bit. And this mixture consists of 1/3 of grasses, 1/3 of clovers. These clovers must not be trifolium clovers, but medicago species, because those, according to Diep Marneser, which we will talk about later, I think, have a different nitrogen root profile, which have more of an ammonium root profile instead of a nitrate root profile, which is important because we have accounted a lot of thistles, which seem to be coming from there in our organic system. And the third part is herbs. And these herbs are actually all the other plants that don't fit in the first two categories. And if you look at it like a diet for the soil, or you look at what the dietary values are on the other side of a product from the supermarket, it is this carbohydrates, the proteins, and all the other stuff, you know? And that's the same what you would give to the soil. And I think it's this tree compartmentalization that gives a very nice full palette of of food source to the soil.
Can you tell us a little bit more about this combination of a third grasses and clovers and herbs or forbs? What are the things you've found to work well?
Yeah, the grasses that stay pretty low will be the ones who are biannual. So if you saw them in spring the first year, they must not go to bloom in that year. Those are the ones that can maybe give a leaf of like a feet or something, which is okay because we swath mow everything for harvest. Um, and there are a lot of these, how do you say, these really perennial, short above ground biomass grasses and high root biomass like Timothy grass and um, um, how do you say, special ryegrasses that are the, say it rightly, in Dutch it is the English ryegrass, and in Germany it's a German ryegrass. So I don't know. I don't know what's in the state, but different ryegrass. They're like, I think there are 7 species we have, which comprise a third of the mixture. Then these clovers is, as I said, the Medicago species, which is alfalfa is one of them. Um, I must look what the names are in English of the other ones. I think I made a list for you a while back. It's black medic, it's birch foot trefoil, sweet clover. Those are the compartments of the legumes, of the clovers. And then as for herbs, that compartment, it is the plantain, chicory, poppy seed, cornflower, caraway, cilantro, coriander, or burnet. And those are more like the spices on the plate, so to say, and they comprise about 15% of the seeds that we sow, but they are very important and for the diversity and the insects, and also the next year that you don't have grasses, clovers, but these herbs. And since we do not feed this grass clover herbal mixture to an animal, we can also have stuff like the sweet clover in it, which has otherwise this blood thinning compound that
Has coumarin
cows
in it,
can
yeah.
pellet.
Yep.
Yeah.
All right. I don't want to lose sight of your comments about nitrate and ammonium because this is such an important concept, and it's becoming more widely known. But this understanding of redox reactions in soil and what that means for soil's disease suppressiveness or disease enhancing characteristics, I'd really like to dig into this a little bit more. And you made mention of changing the Canadian thistle population, which is a very important topic for many growers who are seeing increasing pressure from Canadian thistle. So tell us a little bit more about how all this came about.
Okay, let me go back and then do the introduction also from how we started this whole farming journey. So, and I'll tell a little bit about myself because we dove right in. I am from 1987, and I became a farmer in 2006. But as a kid, I did not care for farming. I was not a tractor boy, and I did a study in psychology and in business school, so I don't have any agricultural study, only what I learned here on the farm from my father. So my parents transitioned this farm in the 2000 to organic after he had a very, very long consideration, which started in actually seeing what happened in the Vietnam War. and seeing that he sprayed the same compound as Agent Orange, be it in a very lighter dose. And in the end, in 1997, my sister, who was then 7, wanted to take a ripe grain, a wheat, from the field, and my father just sprayed it down with a burn down chemical. And he said, "No, you can't eat this grain because I have sprayed poison on it. You cannot eat it. I don't want you to." And he could not explain to my 7-year-old sister, his no, sorry, his 7-year-old daughter, why he would put a chemical on food. And that made him the switch to say, now we really transition. And it was the 2000s, and I came in the farm in 2006, so I had the farm was all transitions, very easy for me. Didn't have agricultural background, and I saw that, you have the organic system and you apply manure and you follow the rules and you have a very, very good system. But it's conventional, but with other tools, you still kill everything. And we were having certain organizational problems in that we did not have animals. So that meant all the manure that we were supposed to use had to be imported, be it organic manure, but that had to come from places far away because the farmers here who had cattle had also good soil and said, "Oh, but we also have a little bit of potatoes and carrots, so we use our own manure. We can use your feed, your grasses and clovers, but you cannot get our manure." So we had to buy that on the manure market, so to say. And with that organic manure came weeds like dock that we had to take out with root and all, and other weeds that we had not seen here before, and also a lot of garbage, which I don't think the cattle or the goat ate, but somehow that got into the manure, which made us think like, why does this grasses clover, this feedstock, has to go through an animal to become food for the soil? Because in nature that does not happen. Not every grass plant gets eaten and gets pooped out before it's being able to feed the next grass plant of fertilization. And we saw also by tilling the soil less and leaving the plow away a little bit, that if you have a better soil structure and you keep it like that, you need less fertilization. And those two combined made us pretty hopeful to maybe develop a system that we wouldn't need to have imported manure at all. And that was a very technical approach that we had. So we tried to calculate how much nitrogen, phosphorus, and potassium we had in the cover crop and what's needed for the next crop. And that was it. And just the technical part of germination is just how to kill a green plant in spring, let it dry out, and try to put your next seed in the ground. But we were pretty alone in that in the Netherlands. We had very little people here who could tell us how that would work. So my father looked on the internet, and in 2011 he found these two advisors in Germany called Friedrich Wenz and Dietmar Nees, who was giving courses about this. And it was the soil course in green, Bodenkurs in Groenen. And they told about an organic system, minimum till, a lot of cover crops, very little animal manure, and how to make that work. And he went for a course there. It was 11 days in 1 year. And the next year I also joined, and we went there yearly after that, not for the full course, but for an updated course. And we we got from them, and also the experts on cover crops and the experts on soil life that they um, invited to their courses, a lot of information and a lot of ideas. But still, they were also on a technical basis. So you have a cover crop, it should be a mixture, it should be of these components, and then you have these special machines to make them away and to sow your next crop. And that works sometimes, and sometimes that did not work. And it was not until the 2014s that they used the term regenerative Landwirtschaft, which was, I think, the first time I heard regenerative agriculture, albeit again in a different language. And from that time on, they shifted the focus, or they expanded their focus also on microbiology and nutrients, minerals. In that, if you have a green growing plant in spring, which is a very good thing to have in winter. Winters here in Europe are so that we can have winter tolerant cover crops. We can also have freeze killed cover crops, but if you have winter tolerant cover crops, you have a living root all year. That's what we want. The thing is, with these crops, they want to continue growing in spring because that's what they do. They also want to set seed. So you have a cover crop in spring that is going for a race, and you as a farmer have to terminate it because, and that's unnatural, you have to turn in a green growing plant because you don't do it with a burn down chemical. So you have to turn in green biomass in soil, and that is unnatural, and that's also not compatible. And in that process, this green growing plant has a lot of energy because if you mow your grass and you lay it on a heap, an hour later you stick your hand in, it's warm, it's microbial energy, and also because you cut it. And if we do that in the soil, so we turn in this cover crop that's lush and vegetative in spring, we turn in a lot of microbial energy, but also a lot of fresh carbohydrates, proteins, and other metabolites that are in those plants. And we want those to be the next food stock for the cash crop following. And that transition is, of course, the microbes cut these green plants into pieces, and then they reform it into their own microbial bodies, use some enzymes, minerals are needed, and so forth. And then you have this microbial population that has grown, and that can be taken up by the cash crop. But you can imagine that if you do not think about this process and you think, oh, the green plant is gone, I have a bare soil and I have a disc cutter and I can sow in it, just technical, but the microbes are still cutting apart these green plants, and you are growing your seed, that environment might not be the best environment for seeds. And also you might
The
have
microbes will win.
that, but also the microbes are also in the part of the process that they have taken these complete proteins and cut them all into pieces into these very simple non-protein nitrogen compounds, which if you move the soil in that part is a scent or a frequency that is a calling card for, oh, here's a feedstock for all the insects and disease to come on feeding. So you have all these seed flies that eat your seeds, and that explains why before, when we were just using cover crops and minimum till, that the one time we had a very good emergence, and the next time half of the seed wouldn't come up, and it was rotting or it was eating, and but we were working with nature, we thought, but we were not. We were doing something that's not happening in nature. Green plants, okay, maybe a deer will stand on a grass and that part of the green will be turned into the soil, but normal green plants won't. They will die first, but we want to maximize that part in agriculture. But we must take into account that process if we want to do that. And then yeah, so I think this is a whole introductory for
Yeah,
where we
this is
came
it.
from. Let's go back to what you wanted to ask.
You've
I hope
just
you wrote it
you
down.
you haven't opened a can of worms. You've opened like 10 of them for us to go into. But thank you for that context. The let's just continue with where you were. Does that mean that today you are? How are you terminating? That's one question that I had. And how are you incorporating your companion plants or cover crops? Are you not no longer incorporating them as green manure? Are you killing them first? How are you thinking about that?
Yeah, so it's um, we are when we sow in spring and undersowing together with the seed crop. The undersowing is after harvest, just we let it stand. Sometimes when we have compaction, which is in very few cases because we have a very light combine and the seed crops are very easily harvested with the swatter and the combine, then we can do a strip till to have subsoiler compaction. We can fertilize if we have maybe trace elements missing or we want to fertilize with an organic source of nitrogen. Then we let this stand over winter, this undersowing, which has like this 20-25 plant species. And then the next spring, this wants to go in reproductive phase. And we use a technique which is actually a shallow rotovading. and it's called the Flechenrotte. So it's a German term which actually translates a little bit to soil surface decomposition. It's not really composting, it's decomposition. And that means that we have a very fast turning rotavator, and we only go about 1 to 2 inches, so 3 to 5 centimeters. And we mix very fine soil because you have a high rotavating speed with the plant parts, which we mulch in front of the tractor with just a mulcher. And by creating a very high, how do you say, um, surface of contact between these soil particles, which contain a clay compound, and these organic matter with very high energy, high microbial energy, and fresh nutrients in them, you create the possibility for a clay compact, a clay humus complex to form. And this has some, how do you say, conditions that must be met. So that means you create a very high amount of microbial breathing because of the energy you put in by the machine and by what's in the material. That means that you should not cover the soil airtightly. So there should not be a big roller behind it. There can be a very light roller or no roller behind it. So you have these gas exchange. And the next thing is that you have to, or you should better try to steer this process with a microbial inoculant. And in this case, it is a herbal ferment, which is actually a antioxidant or reducing compound, which has a pH of less than 3.5, which is mostly lactic acid bacteria, yeast, and photosynthetic bacteria, sometimes called EM, but we have a different kind. We make that ourselves. And this material is sprayed at the plants before they are mulch and right like a couple of seconds before they are incorporated. We do that in one pass. And this makes
So you have the
sure that,
mulcher, in front of the tractor and
yeah,
incorporating them at the back. Yep.
yeah, exactly. And this using of these ferments ensures us that it is in a good direction, this process, because in spring it's oftentimes not ideal conditions, but you must work the soil, you must terminate the cover crop before your cash crop can be sown. And it is the same that a, how do you say, in a silage pass, they would use also these kinds of inoculants to make a good silage. And when you
Yep.
ask a dairy farmer, when do you need it? And they would say, well, if conditions are not optimal, then
Right.
I would use this to have a good silage. And it is, we are not creating silage, but we want to steer the process in the right direction. And then afterwards, you have done this pass. It is about between 2 and 3 weeks that this process takes, depending of temperature and moisture. And then you can observe in the soil crumb structure, the color, and you very distinctively the smell, which has like in the first 3 days you have a slightly sourly smell. Then you have a week of almost no smell, and then it turns a little miffy. And at the end of that part, you have this sweet forest smell, and there's these actinomycetes and so on. And when you smell this, you know it's ready, and you must look if you have emerging weed seeds, and if that's all clear, and that's almost not there because of the nutrients abound, then it's safe to sow your seed. And
This I'm thinking about the implications that this process that you've just described has for disease suppression and developing a disease suppressive soil. And it's a very different process, much more, I don't know if designed is the right term, but it's a very deliberate process. It reminds me in some aspects of ASD, anaerobic soil disinfestation. And but yet being a much more natural process, whereas with ASD we are purchasing and bringing in all these various carbohydrates and all these various feedstocks and potato starch and beet pulp and whatever the case might be that people are using, where you are actually growing this with a crop and then incorporating it very shallowly. I love the way that you've described this.
and what's very important is that you have a lot of roots in the soil. So this process will only work if you have a gas exchange to the air, which is not hard, but also through the soil. And there are a couple of
That
things that
that
are very
aspect
important. That's
that
very
aspect
important
is the
because,
opposite of ASD.
yeah, and what's very important in this is that you do not create a smear layer. So it means that with a certain rotating speed, you need a certain driving speed. That's one. And the second part, not to create a smear layer and to create gas exchange to the soil under it, is enough roots. So if you have grasses, clovers, and herbs in one mixture, you have enough roots. But if you have just a radish cover crop, so to say, this process will not work. One, because what you are feeding is just a radish, which is very um, not diverse in nutrition for soil life. And secondly, because you do not have this perforation and this root zone, this appendix that you want to leave for the reinoculation. When this process works, you can till the soil like 1 to 2 inches. And then if you have a tillage equipment, you can pull it like a knife through butter. After this process has really followed the right, um, how do you say, came to an end, um, it is amazing how much more soil crumb structure you create by just tilling a very small part. So
To what depth? How
yeah, to
deep do you see the soil crumb structure developing?
20 till 25 centimeters, which is like 10 inches.
Yeah.
It's amazing, and it's it's so nice what you can do with tillage in combination with setting in motion a biological process and meeting all the conditions that are need to be met. And we have talked about the machine, we have talked about the microbes we put it, we have not talked about the minerals, but there must be, for instance, sulfur to form all the amino acids that all these microbes want to form, and so on and so on. So those conditions have to be met. And if you have those conditions met, you can set in such a nice process, which takes you a little diesel and a pass on the field, but makes the soil that much looser because of the microbial action. And the nice part is this is an incredible multiplication of microbes because you're feeding them at a very specific way, high intensity feeding. And the nice thing is that we measure now that our organic matter in soil has risen steeply. And since we have barely transported any manure nor compost to our fields, that must come from the microbial, um, how do you say, proliferation.
What I think I'm hearing you say is that when you are incorporating this cover crop shallowly and rapidly and with very fine particle size, and you have good gas exchange, when you are developing a crumb structure to a depth of 10 to 12 inches, that means that the microbial activity is not limited to that upper tillage layer, but that you also have this microbial fermentation process, this decomposition process that is also acting on the plant roots and decomposing the plant roots that you did not touch very rapidly.
Hmm. There is a there is another part about that, of course, and you know I cannot explain that very well. Deep Morneser can. It is about, he says, on this plant root tip, you have these exudates of sugar, and because it is a little bit like in the Flechenrotte where you put in a lot of sugar in the soil. Maybe you can explain this better to me, John, because we're always talking about the oxidizing in the rhizophagy cycle, that the microbes get sucked in, oxidized, and spit out again. But at these root tips where there's lots of sugar that is consumed, that consumes also very fastly the amount of oxygen that is in there. And mostly the oxygen, so it gets anoxic, not anaerobic, but anoxic, without oxygen. And it is in this very small piece that there is a fermentation process, because the metabolism continues but without oxygen. And when your metabolism continues without oxygen, you have a fermentation. So there the circle is round again.
As you have how long have you been using this practice of incorporating cover crops and with these microbial inoculants, and what have you observed from a disease resistance perspective or disease suppressiveness perspective?
Yeah, so let's get back to the timeline again. When in 2014 we went to the course in Germany and they started call it regenerative agriculture, then the focus on the microbes and the minerals and also the compost teas and so on came with that. And about 2 years later, we were needing help on the farm in having that explained to us at our level and not our farm and our specific needs. So we asked Dietmar Nezer to come to us, and he traveled all the way from Germany to our farm, and he was here for 1.5 days. And I wrote about 10 pages when he was here. He's so knowledgeable. He then also said about there is this plant head pyramid, this John Kempf guy, and I don't know, just it was like 3 years later that I saw that I wrote that down what he said when I listened to your podcast, and like, oh, he said that 3 years ago. I was not paying attention. Also, your podcast was not everywhere at that time, I think. But anyway, so he is very that brought us a lot when he came here. At that time, we were still using a lot of frost-killed cover crops with a lot of legumes. And in an organic system that doesn't want to use a lot of manure, we thought that was the wise thing to do. And he came and we said, but we have all these thistles, we have bed emergence. And it was in that time that he said, yeah, we now have this technique called Flechenratte. And for this technique, you need a lot of grasses. And we said, yeah, but we have sold our plow and the plowing is bad, But in this case also, it's the how, it's not the plow,
Exactly.
And he said we have the Flechenrotte now, and it is okay to plow if you do it like 15 centimeters, like 6 inches. You can inject ferments behind the plowing blades. If you drive not that fast, if you also take care that there are still enough roots in the soil, like the appendings from where the microbiology can be inoculated again. And with the incorporation of grasses again, and the incorporation of specific tillage methods, we managed to finally get this crumb structure way down. Because in the first 10 years of not plowing and using a lot of cover crops, it was only about a couple of centimeters. And after these techniques, it really went down a lot. And that also finally gave us good emergence and very good growth. So where we had a lot of problems with caterpillars in brassicas. So brassicas are like nitrogen junkies. They take up a lot and then they have too much and they get attacked by everything. We saw that with a well-prepared Flechenratte and together with a companion crop that also could buffer some of these nitrogen excesses, even in an organic system, even without manure. That's possible, I can say. That has gone a long way for us, and we have been able to produce germination rates which are above average, mostly above 95% even of crops that people don't say that's possible, like nasturtium, which is the rate is like 80% you have to have at minimum, which is very low, and we get about 90 or 95%, which is we are very happy with that. Yeah.
Yeah. So for our listeners who are listening to Flächenrotte is, as Erwin described previously, perhaps the best translation is surface decomposition.
Yeah.
Decomposition just on the surface, but decomposition in some sense also almost doesn't do justice to the process that Erwin is describing. It's almost like fermentation, like making a silage or a sauerkraut or a yogurt or something like that.
Yeah, still, but it's not yeah. The
Yeah.
process is not fermentation. Yeah, it's Rotte in
Yeah.
German, and Rotte is a good decomposition. It sounds like rotting, but that's a
Oh,
foulness in German, and that's a really different thing. Um, and it's not just the decomposing of the plant particles; it's the rearranging and building up. So as they describe it, the Manes and Friedrich Vens, you have this U curve which you have the taking apart, which is going down, and then you have the reorganizing, which is the horizontal line, and then going up, you have the rebuilding. And it's at the end of that U curve that it's ready. And if you in the line going down, in the taking apart, are showing your seed, then it's not conducive environment. But you have to wait until this process is done, and then
Well, something that you said earlier that really caught my attention is that in this building up process, you have the opportunity to form a humus clay mineral complex,
yeah,
which is that's the foundation of good soil aggregation. It's the foundation of very effective mineral nutritional delivery
yeah,
and
because
building
you
up
are
soil health.
feeding you're feeding the soil life, the microbes on the leaf, and the very fresh, like it's like salad fresh leafy greens, um, to the soil. And that combination with these clay particles, that is very effective. That also means in a sandy soil, they are advised, and we have some sandier soil, not that sandy, but it's not pure beach sand, but it's pretty sandy. You have to do the tillage deeper, so you have more clay particles to buffer it with. And if you have no clay particles, you should add zeolite or another rock dust buffer material with high exchange capacity.
So you made a comment a bit ago that the mineral nutrition is required, adequate sulfur levels are required. How are you managing the mineral nutrition aspect?
Yeah, so we take just an Albrecht soil analysis, and we do not follow that by the letter because that's not necessary, as Dietmar said in 2016 when we took that soil analysis for the first time. Because it's not a standard in the Netherlands, and there are other standard soil analysis. He said, like, most of these soils have sulfur missing, and the advice was to spread like 110 kilos of elemental sulfur. And he said, we are not going to try here to have a perfect mineral balancing sheet, and we're not going to spread these high amounts of fertilizers that are advised by the lab, but we are going to combine fewer amounts with biological measures. So, for instance, in the sulfur, we spread 25 kilograms of elemental sulfur yearly, and we mix that together with the seed. And we can do that in spring, and we can do that with a cover crop in fall again. And by this, you have these elemental sulfur in the root zone with the highest activity of young growing plants, where you have like this biogenic measure. And in that case, you need less. The same is for the magnesium, because we have a calcium saturated soil. We should use magnesium. And the advice was 1,000 kilos of magnesium sulfate in 3 years. So it's a lot. And he said we're going to do 100 till 125 kilos yearly, but we're going to do that right before we do the Flechenrotte. So you put it into this biological, very active process where every part of that nutrient, of that atom, is being utilized by the biology, and none is going to waste. And I think that is very good. And what we see in our soil reports now, the following years, that magnesium has gone up like 3%, which is not accountable for the amount of magnesium that we spread, which is way less. Humus had climbed from 2 to 3.4 in a couple of years, which is also not accountable for the carbon that we brought with the truck, because we almost didn't. Sulfur has gone from, it was like 10 to 50, with only 75 kilograms of sulfur. Um, so that's the part from the soil, and that works good. And then we do the plant sap analysis, which we have been doing for almost 10 years now. 2016 we started with that, so we have a lot of data sets, almost as much as you, I think. No, just kidding. And what we see is that especially in the beginning, we had still a lot of micronutrient deficiencies because of our high pH, high calcareous soils. And we see, especially the last years, that the baseline, so even before we put on out foliars, is much better than it was before, and is better on micronutrients and also better on calcium, and which you might think, or you might not, but people might find weird that in calcareous soils you would have low calcium in your plant sap, but that was the case.
Very
Um,
common.
and it was even the case on the soil that has a very high, how do you say, shells from the sea, because it was 150 years ago was sea. And on that soil we had very low calcium, and Dietmar said to us that's a function of fungi in the soil, and these fungi you can promote the best by grasses because they love the carbohydrates that they attend. And when we incorporated grasses again and stepped out of the focus on purely legumes, we saw a very high increase in the standard calcium values we have on the SEP analysis, which is something we are very happy with, because that translates to a lot of disease resistance. Because in a young stage, you need these cell walls to be very good supplied with the calcium, because then in a later stage you won't get mildew and stuff like that.
We started this very fascinating conversation by me asking you about Canadian thistles, and you haven't yet answered the question about Canadian
Oh
thistles.
yeah, that was sorry, taking off track here. So
No,
about
it
these
was a
Canadian
good track.
thistles, yeah, it was good. So about these Canadian thistles, most of them have gone away. I saw yesterday I have this one patch where there have been carrots last year which have been harvested in December under not that good conditions. So it is explainable that they are there, but I saw that all, without an exception of one thistle, of this Canadian thistle, is eaten by caterpillars. So they are in the leaf and they're curling these leaves, and you see all this caterpillar poop, and they're scraping the leaves. It is, I think, the same caterpillars that also eat nettles. It must be one special kind, because those are not plants I would, as an insect, love to go to first. So I'm not worried about those, and we have seen those really almost disappear here. The same goes for quackgrass, which on the lighter soil was an enormous problem. But we, through the sprayings with compost tea, I think, and through the higher calcium amount, through more fungi, through more grasses in soil, the quackgrass has disappeared. There's only one perennial sowing thistle, which still causes us problems, and I have not found the exact way to get rid of that. I'm thinking now, because it has the same nutrient profile as a chicory. So we made a plant sap analysis of a lot of weeds and also of this one, and it really compares to chicory in that it really gathers potassium chloride and has no molybdenum, and has pretty high nitrates, I thought, and that correlates to the chicory standing on the same field in the potatoes last year, and so I think we're going to sow more chicory.
What do you attribute the reduction in the Canadian thistles to? When did things start to shift very rapidly? Is there any particular practice?
Yeah, I think one of the most important things is having the soil in a vegetative state and not being tilled more times in the year than only in spring. That is very important. Secondly, through that you get a nice crumb structure. I think that's something they cannot stand, because they're always growing in compaction, which creates a nitrate layer. Thirdly, getting out the nitrate trifolium clovers out of the mixture, which is very important. Not only having clovers or legumes in our cover crops, very important. And I'm thinking that, but I don't know. It's a whole system. I think the sprays with the compost tea have an effect, because they're boosting the crop in photosynthesis capacity, and I think that's for the weeds. It's the other way around. And we can talk about that now, about the mulching. Um, we have this mulching system for potatoes, which means that for 1 hectare of potatoes, we have 1.5 hectare. You can translate that to acres, of course, of mulch growing. So we do that within our own farm. So we do not import mulch. And that means that this mulch is sown in the first half of September, and it is a rye and a vetch. And this rye and vetch will be after the next year, half of May, have bloomed and is ready to put on the potato fields, which means that it is about 2 meters or about 6 feet high and has produced about 10 tons of dry matter biomass per hectare. So that translates to about 15 tons of dry mass per hectare on the potatoes, which create a layer of about 8 centimeters of mulching material.
How finely is that chopped?
About 2 centimeters, about an inch. Yeah, which is important because then you need less mulching material because you have a closer sheet.
Yeah, it compacts down more.
We can get back to the potatoes later, but to the field that has been harvested for mulch, it's like the donor field. As you have a donor field and a receiver field. Receiver field is potatoes in this case. Donor field is where the mulch came from. That field has been dark all spring. So every root weed that emerges there comes in dark because this rye and vetch is very dominant. Then you take it all off. We have tillage pass that is pretty aggressive. We do a shallow plowing of 15 centimeters, and then we make ridges and then we make the carrots on it. And we have seen that in that system, you can get rid of a lot of these perennial weeds in 1 or 2 years. And so that is also very effective. So this combination gives us a very good way out of these perennial weeds, so to say, which have been coming to us since we tried less plowing and a lot of cover crops that were leguminous based because we didn't want to use manure. So I think it is a heritage out of the development of this system that we had in the past. But we have to live with this heritage and we have to find a way out of it that is not so destroying. Because if you go to the normal organic advisors, they would say you take August and when you harvest the crop, you till the soil bare and dry until there is no moisture left and then the thistle will die, you know? But in that process, you will burn the last tenths of percents of carbon that you have because you will volatilize and oxidize everything that's still in there, you know? And then the first thing that will come again in such a situation the next year is the very thing that you would want to get rid of. So I'm glad that we have found our way now. That is a life promoting system in which these perennial weeds don't have a place anymore. Yeah, so we don't have to take them all out by hand, you know.
Let's go back to the potato crop. So you are applying the mulch. Do you also do any intersowing or planting else anything other than potatoes in that
Yeah,
field? And also give us some context for the scale that we're talking about.
yeah. So we have 20 hectares of potatoes. So it corresponds to what is it, 50 acres.
50 acres, yeah.
Yeah, and for that 20 hectares, we have 30 hectares of mulch. So that means out of our 85 hectares of farm, which is in this side of the dike, which is not the other part where we don't farm, we have 50 hectares, which is either mulch for potato or potato itself. After this mulch, we grow carrots, we grow peas, and you could grow other, mostly vegetative crops because you're at the half of May, and a lot of seed crops. Peas can go because they're not that day length sensitive, but other crops like mustard will do worse. So and a carrot is a vegetative crop the first year, and that is less time dependent. Anyway, so we spread that on the potatoes, we have big tracks every 15 meters. So we have two ridges that we do not plant, where the very big um, manure spreader can go through, but there's not manure in it, it's mulching material. We have a contractor here, which has just the normal, how do you say, feed collecting for a dairy farm machinery. So he has a chopper, and they mow it, they chop it, they put it on a manure spreader, all in very close, tied together, because we want to keep as much moisture into the material as possible. And it's not because we want the moisture on the potato field, but it is because we are at the sea here. We always have a lot of wind. And as soon as we lose moisture, we cannot spread it that broadly. And we want to be able to spread it as broadly as possible. So we need as little as tracks as possible, because that is a loss of potential potatoes that could be grown there. And then the day before we do the mulch spreading, we go with this very big harrow, which is very broad, and we have a sowing machine on it, and we sow. Is it buckwheat, oats, fenugreek, peas, all pretty big seeds, just before, and then through this harrowing, it is all going through in the talls of the ridges, in the lower part. And then this mulch a day later gets on it, and now you have the potatoes, and some varieties have very big foliage, and some are somewhat upright and more open. And then in
So how
between now
much
you see the
once your seeds germinate, what proportion is the cover crop almost entirely in the valleys, or is there still a little bit on the ridge?
I would say 90% is in the valley, yeah, and 10% is maybe on the ridge. Those
Yeah.
seeds have not been harrowed down, so to say, but that is not a problem at all at harvest. And then
Yeah.
so now you have these nice strips of flowers between the potatoes. They help each other very good, I think. And then we terminate at size, because as seed potatoes, they must not get too big. And then we have this special leaf puller, two rubber balls per row that pull out the haulms. And that makes us being able to harvest within 1 week of haulm pulling, which is mostly in August. And when we harvest, we have this special harvester that goes on small tracks with a crate in the back, with harvesters direct in the crate, so very gentle. So that's why we can harvest so fast. And last season, we made a small seeder on the harvester, because the soil is not disturbed that much through the light machinery and on tracks. We made a seeder, and we sown buckwheat, oats, and camelina, three of the fastest growing plants I could think of. And because we have all these different varieties of seed potatoes, some are harvested at the beginning of August and some at the beginning of September. And in our rotation, after a potato crop in September, always the mulch for next year's potato crop is sown. So we recycle these nutrients. And that means that sometimes there is a gap in August for 4 or 5 weeks between the first harvested variety and the latest one. And I thought, how can we regreen that? Because otherwise, unwanted herbs will come. So we sown this, and between the first and the latest potatoes, there was like this almost a 3 feet high canopy of this oats, buckwheat, and camelina grown there, just in these 4 or 5 weeks, cycling these nutrients. And we turned that in and sown the next mulch crop, rye and vetch, for next year. We have seen in our potatoes, we have had a lot, and I call it also a heritage pest, wireworm, because I think when we were not doing things right with a lot of focus on legumes and frost-killed cover crops, that we have introduced the possibility for the wireworm, or the click beetle as the mother of that. And these wireworms can survive 5 years. So maybe I did something wrong 5 years ago, and now I still have this wireworm. Then again, if we make the potato plant or the environment in that ridge so disease or pest resistant that we have no problem with that, that could be an answer, I thought. And it was because of this mulching system that we did 3 years ago, together with very intensive nutrient management through at planting and also at the leaf, that we have a reduction of about 90% of this wireworm problem, which
Wow.
we were really at the brink of that we had to stop with the potato growing about 6 years back, and that is one of the most remarkable things that came out. Yeah.
Wow. Yeah. Yeah. So when you were spreading this wet chopped rye and hairy vetch as mulch, chopped down to 1 inch, you've planted these very large seeds. How thick is the mulch?
It's about 3 inches, so about 7 to 8 centimeters.
3 inches when it's fresh or once it's compacted?
When it's fresh, and a couple
Yeah.
of days later, it shrinks about 30% of the size. Yeah.
Yeah.
Now these big seeds will grow through.
It'll
Yeah.
come up through that. Yeah.
Yeah. So and now we have a potato growing system, and it's actually kind of funny. We did not think of this mulching system ourselves. My father came across in 2008 a farmer in Austria called Franz Brunner who did this because he had a problem with potato beetle, which devastated all crops there. And we thought, oh, with this big spreaders through the potatoes, this guy is crazy, you know. But he showed that the part that he didn't mulch, and later at the University of Kassel in Germany, they confirmed this. They had a lot more potato beetle damage, and it took a couple of years. It took the last 5 years that we had 3 of those years record droughts, and we are prohibited to irrigate our seed potatoes here because of a quarantine organism in the water. Which means that we had a yield drag in that crop, which is a very intensive crop to grow. Also, financial wise, you put a lot of money in the ground, and then it didn't seem so crazy anymore. So we heard a farmer in Germany on a larger scale doing that, and we asked him about his details, and then we applied this also. And we have had the wettest season and one of the driest springs, and it is just under all conditions given us a very stable and qualitatively high yield. Whereas last year we as organic farmers in Holland had just a 50% yield of normal, we had a 80 or 90% yield of normal.
So what are the factors that contribute to less potato beetle pressure? Is it just because the part of the plant is covered in mulch for a critical period?
No, actually you spread the mulch right at emergence. So the plant can be like 10 centimeters up, and then you can spread, but ideal is at emergence. What they found out in Kassel at the Regenerative Kartoffelbouw, so regenerative potato growing project, was that the first flight of the potato beetle was the same, but about 50% of the larvae hatched less, had less hatching success. So the second, the the beetle's not the problem. The larvae eat the
Right.
potato, and you have 50% less larvae. And they shown very nice drone images from above that the small box plots unmulch, 80% of foliage is gone, and the small box plots that are mulched, only 20% of foliage is gone. And it is, they say,
Intriguing.
because of this mulching, the larvae the eggs are not being able to hatch, you know. And I think they
Why,
also they also use for aphids straw in potatoes, seed potatoes, like as a yellow deflecting. You know, it's the aphids get confused, but we are not using straw. We are using something with a lower CN ratio at a very higher mass. It's also yellow when it really when all the, how do you say, the green stuff out
when
of
it
the
dries
plants is
out, yeah.
gone. So there can be a confusion part for the aphids, but I think a very much more important part is that the plant health gets higher because these roots of the potatoes, you see them grow, show that the part where the ridge is driven by with the very big machine, which still has mulch, but the root system is compromised through compaction, you know, by turning a corner of the machine. There, the potato beetle eats the potato, and not where the ridge is untouched and nicely mulched. So it is a plant health aspect also, and we are trying to figure out what it is, because every year we take a lot of tarps and we make all these control fields where when they spread the mulch we take the tarp off later, and we do plant sap analysis. So my father is busy 1 day every week to do plant sap analysis, and we have now for the third season, which is almost finished, and we still have to dive into that, what it says, the difference between mulch potatoes and non-mulch potatoes, and we are curious if we can find anything there.
Fascinating, because the question just keeps going through my head: is what if you have poorer egg hatching rate and the larvae is not emerging from the egg on the mulched zone? What are the mechanisms behind that? What are the drivers of that? Is it light reflection? Is it heat? Is it soil root development, or plant root development and soil temperatures? There's a lot to unwrap there.
I think they have a good conclusion of that at Kassel, so you should ask them. And I cannot remember exactly, but there is a reason for the potato beetle, or the hatch success rate of the larvae, um, which is a difference between a bare soil under potato and a mulch soil. And I don't think they looked at plant health like that. I think they looked more at it like a mechanical difference between the environment underneath the potato. But this one observation from this Austrian farmer who said, with the root system of this ridge damage through the driving on it, that steers in the thinking of it's also a plant health aspect.
Yeah. Yeah. Fascinating. Absolutely fascinating.
And same goes for late blight. So late blight comes from the soil, right? So you have this spore forming from the soil going and infecting the potato. And now if you create a layer that prevents soil particles from bouncing directly up to the leaf, you also create a barrier for that. That's the one part. And the second part is you create lower humidity. So we have measured with sensors that under the canopy and the mulch in between that zone, you have about 10 to 15% relative humidity lower during the season in comparison to a bare soil. And those two factors are, I think, very important for delaying late blight, which also in Kassel they researched and said it's about 2 weeks later. And especially in organic system, like last year, where the organic sector here in the Netherlands had a very low yield, that was contributed mainly to late blight.
What other disease challenges or insect challenges have you observed shifting with your change in management practices?
There has been a lot of insects in our brassica crops, which are our main seed crops. And I must say we have been able to conquer or prevent most of them. And as said, only for the flea beetle, because we get seed as stock seed, we must do something in that very first part of the plant's life, because this flea beetle can be so aggressive. If you see a seed germinating at noon and the dicot leaves could be at dinner, they could be gone just 4 hours later. That is a very hard one, because we do not have influence, because it's the seed that you get. And a lot of the caterpillars that turn up when the plant is bolting, which is a very vulnerable stage in the plant's life, we have been able to prevent them with balanced nutrition from the Flechenrotte process and plant sap analysis and steering by through the leaf. So we have seen that molybdenum levels are steadily very high now. Boron is very high, sulfur is very high, but magnesium is still lacking because we are not yet at a very good ratio in soil. We've come away, but we have so much calcium that's prohibiting a lot of the magnesium probably. And we see that that's the missing link, and it's not that we can spray magnesium sulfate, but it's not that easy to get it to the plant. We also don't want to have burning, it has high EC in the spraying mix. But a lot of the fungal diseases have pretty much disappeared. Yeah, like the mildews in the carrots and yeah.
How are you hoping to evolve? What further changes do you see coming in the future in your cultural management approaches?
I would like to expand the mulching onto the seed crops too, because we see what a massive positive effect this has on potatoes, and we see also what a massive positive effect it has on the soil that has come from the donor field, so to say, who gave the mulch to the next crop, um, because we get a very clean start, and also it enables us in this system to produce a lot of biomass in our rotation. Because when you have a rye and vetch which you terminate in April, you're missing out on so much biomass. And this biomass in May, you cannot turn it into the soil on that field. Because if you have like 10 tons of dry matter, you try to do a Flechenrotte, it will take too long. The CN ratio is too high, and the soil cannot make a crop of it that year. You will not have a cash crop. But when we transfer it and leave it on top, and okay, you lose probably more carbon dioxide to the air to the oxidizing of this material. But then again, it is in a green crop with the stomata, hopefully recycling a lot of that carbon dioxide. But it gives us in our rotation a possibility to grow a lot of biomass in the rotation, um, which I think we want to expand also to planted seed crops. So I'm thinking about carrots for seed, onions for seed, um, and if we can grow them in a mulching system, those are crops which have a lot of insects and fungal problems, so to say. So the mildew in the carrots, and there is a specific insect the mildew in the onions, and in the carrots, this specific insect that eats the embryo out of the seed. Which in organic system they have not found a lot of answers for, and I think in combination with this mulching system, that we can work towards a solution there.
What have we missed talking about? What recommendations do This has been such a fascinating conversation, and I mean, I've certainly, I've watched your social media posts, and you and I have had previous conversations, and so I knew a bit of what you had going on, but this has been a fascinating conversation for me, and I'd love to learn what is it that you're working on that is, in addition to what we've talked about, that is quite different from the mainstream or that might be unfamiliar to many people.
Can we leave our own farm for this discussion, or do you
Of
want to
course.
stay on your own farm?
No.
So we saw that when Dietmar Nezer came here in 2016, and in this 1.5 day, he told us so much more that we needed to know. We have given the course with him here from 2019, and we have seen that there is a lot of interest for farmers, not only to take this course, this regenerative agriculture course, but also to get guidance from him. And the issue is that he is just one person, and there are very few advisors who can advise like the way he does it, like on a practical manner, and giving so much, how do you say, um, context. So he knows things to combine. As I said, he mentioned your name like 3 years earlier, and I did not even know what he was talking about. And we have tried together with two other peoples to make this more structurized in a foundation. So we have founded a foundation which is called the Dutch Regenerative Alliance. Not to be confused with the European Alliance of Regenerative Agriculture. We are partners with them, but we have the Dutch Regenerative Alliance. In this alliance, we are trying to make his agronomic, and not only his, but also from other consultants and agronomists, which are very good in the regenerative way, so to say, in Europe, to make that available to a lot of farmers. Because what we see is a lot of farmers take the course and they say, "Oh, it's very interesting," and then they come to their own farm and say, "Oh yeah, but I don't have this rotavator. What other tillage can I use to make the Flechenrotte?" And okay, and now it's very dry, and I want to do the Flechenrotte. Should I irrigate? Should I use a roller, and so on? And it is these specific questions that a agronomist or an advisor at the farm gate or at the farm field should be able to answer. And since we have too little, we must find ways to make that more efficient. And that's why we founded this foundation. And in this foundation, we are doing a couple of things. One is developing an e-learning, which is online now. It is still in Dutch, but we want to make it in English in this fall, which gives deep Monases a course, which you can take then from all over the world, which has other e-learnings too. I want to do a small e-learning on mulching the potatoes, what you have to take care of, all the practical stuff like what kind of spreader do you need, how long should it be chopped, when should you sow, what rates, and so on. And a next thing is that we want to set up a community. We do that in cooperation with the Swiss community called Regenerative Schweiz. And what they do there is come together online every 3 weeks. And it's like an Ask Me Anything, like the sessions you have done with an advisor. Only small differences here also that farmers can talk to each other. So when the advisor gives an answer, he also says, oh, and maybe someone from the audience also has an idea about that. And that's very valuable. We work together with them to create that in Holland here. And then as a next thing, we want to record those sessions, so to say, and make a searchable um, platform in it. So if someone wants to know what the perfect recipe is for composting and temperature and so on, one advisor should not repeat that question all the time, and you should just be able to search and just find the answer in a video part. And I think it's a little bit like the thing that you launched just recently, like you don't want to say the same answer all the time, so you put it in AI and just ask the question and roll out.
Yeah, we have. Well, we did two versions. We did one. I did just a digital clone of my own, or an avatar of my own information. That so it's just trained on my own
Yeah,
information. But then we have also launched FieldLark, and I don't know if I may have missed giving you early access to that, but we're going public launch here in the next week or two. We've given a large group of people beta access to it for the last month, and people are just blown away by the quality of the information they're able to get. So yeah, I would love
nice.
to incorporate that into the work that you're doing.
Yeah, so and that's very good if we can cooperate on that, because what we are seeing, and that's the same as you described in the launch of FieldLark, is that there are just too little people who can go to the field and help the farmers. So we must find ways, digital ways, in which we can make that more efficient and still stay. Yeah, can you still stay connected? It's digitally connected, but we want to fit in this community that the farmer actually talk to each other also, and exchange experience. And what we have seen that is missing here in Holland for a big part is that the collection of data. So we don't want to be a dogmatic regenerative agriculture, like thou shalt do this and listen to this book, that Dietmar Nezer wrote, which is a very good book. But we want it, and Dietmar wants that too, to work it in practice. And we want to exchange with each other, but we also want to sample data. So farmers who are doing this take plant sap, take soil data, take whatever we can get, measure the plants also with, your own harvest data, and by that we try to hope to build a database to have a little bit of a foundation underneath what we say we think is right. And we also partnered with the Bionutrient Food Association to we analyze the crops for nutrient density for the farmers who work with this system. And it's just for the first year. We did that last year, and it's very nice to hopefully get something out of this that backs it up a little, because anecdotes are very good, and we have a lot of that now. And we need a little bit more. It shouldn't be scientific, but at least anecdotes from several farmers instead of one.
Yeah. This has been a fascinating conversation, Erwin. Thank you for being here. Thank you for all your work over the last couple of decades, for your innovation, for your leadership, and for being willing to share all the work that you're doing. Thank you.
Thanks, Jan. I had a blast.
The team at AEA and I are dedicated to bringing this show to you because we believe that knowledge and information is the foundation of successful regenerative systems. At AEA, we believe that growing better quality food and making more money from your crops is possible. And since 2006, we've worked with leading professional growers to help them do just that. At AEA, we don't guess, we test, we analyze, and we provide recommendations based on scientific data, knowledge, and experience. We've developed products that are uniquely positioned to help growers make more money with regenerative agriculture. If you are a professional grower who believes in testing instead of guessing, someone who believes in a better, more regenerative way to grow, visit advancingecoag.com and contact us to see if AEA is right for you.